In continuation of our previous simulation of 2D of manipulator, today we can see that another set of simulation. We will selecting the number of degrees of freedom. Again, consider it can be 2 degrees of freedom in this case. In the last video, we have been used on 2R kind of manipulator. Now check with that what will happen if it is going to be a 2P. 2P means two prismatic joints will be available. So on selecting this 2P, we need to enable this load selected robo. Once you selected this one, you can observe that there is a change on the workspace. That will be, you can use a scroll mouse for zooming down and a scroll mouse with an zoom up. Up and down will be controlled by the scroll button in the mouse. And when you are checking at over the joint information, you can see that there is the two joints are there. As it can be a 2 degrees of freedom is available, here it can be a 2 joints will be available, that is other prismatic in nature. In comparison with our previous 2R manipulator, the joint offset value will be previously it can be 0 0. Now it will be defined as a variable. As these joints are in prismatic in nature, that is a linear joint that has been attached to that both the joints. Both the joints as in linear in motion, so it has been that the prismatic joint has been preferred. So again, the based on the arrangement of the respective links, it's about the joint angle is about 90 degree and the link length as it can be connected to the same link, it is given as a 0, that twisting angle is 90 degree and the other parameters it can be a standard default condition has been provided. Let us check with that. Here this is the characteristics of this robo is concerned. Joint type is prismatic, joint offset is the variable and the joint angle is can be 90 and minus 90. The link length are 0 and 0.15. So, the 0.15 is going to be the second link length. The twist angle will be of 90 degree 90 degree. I will be presenting these details in the next coming video. So, further here you can consider that the kind of the limits we are going to provide is going to be at 0. The joint 1 moves from the 0 position to a 0.3 position. Similarly, the joint 2 will be taking from the 0 position to a 0.2 position. So, considering the nature of the joint, in this case it is going to be both are prismatic in nature. So, this value will be in terms of the meters. If you are selecting the 2R kind of manipulator, these two joints will be in degrees. So, as our case is concerned, it is going to be prismatic. So, the first joint moves from 0 to 0.3 meter, whereas the second joint moves from 0 to 0.2. So, just based on this setting of our the robo configuration, let us see that how this analysis happens. So, as I said earlier, it can be F kin represents the forward kinematics, I kin represents the inverse kinematics, I dyne represents inverse dynamics and F dyne represents the forward dynamics. As this module is concerned with the kinematics, we will be addressed to that forward kinematics and inverse kinematics. In this example, we will be doing the forward kinematic analysis. As we are giving the values of the joint positions, we like to find out what is the end effector position. Therefore, it will be considered the category called forward kinematics. So, once you click on this forward kinematics, there is a notification that whenever you click on your forward kinematics, the notification will be of analysis complete. Once it has been done, this gray colored button will be turned to blue. This shows that the analysis has been completed. Let us see that how this simulation happens for the given conditions. On clicking this play button, you can see that there is a motions you can observe. So, this will be happens because of This is a one of our sliding joint, and this is also one of the sliding. Sliding means a linear joint. In this case, it will be declared as prismatic joint. So, can we play back? So, the same thing happens. You can observe that this is only for the simulation purpose that it has been used. We can take in different levels of it. So, in this case you can observe that this black color line, it represents that it's the movement of the end effector based on the motions on the both the joints, you can observe. So, in order to take the behavior of it, you can take the graph tab and you can check on where the joint information, that is called joint value. Again it moves from the 0, it goes to over 0.3 meters. Similarly, the joint 2 will be taking the 0 to 0.2. So, you have two joints will be compared simultaneously. Similarly, we can see that what happens on the joint velocities. So, joint velocities are in this fashion, it has been observed. In the next coming module, we will be discussing on the trajectory planning part. So, there you can understand why this shape has been achieved and what is the implications of it. However, without knowing the information of trajectory planning, we could experience the visualization using this package. So, let us try with the joint acceleration of joint 1, and this is going to be a joint 2. So, we will be getting these two joints and their profiles smoothly. So, you can observe that whenever you move from 3D model, you will get that experience of the robo behavior, whereas when you are going to a graph, you will get that the graphical representation of each of these joints. I hope that you can try with an other 2 degrees of freedom. Let us consider it can be a R, P and R. So, while loading it, you can see that there is a difference on it. Scroll down will gives you the differences. So, in order to get this more visible, so you can take these values in a different way. So, instead of the link length, I will provide 0.5 and press enter, or you can move to the any of the tab, it will be reduces to the respective element to it. Once it has been there, you can see that what is the nature of the joint type is can be a prismatic, joint 1 is prismatic, the joint 2 is revolute. So, you can observe that the joint offset is variable, joint angle is variable. The other values we can change it and see the behavior of it. So, you can see that there is no blue colored lines here. This will be enabled once you enable this FKIN. The analysis is complete, that information happens. Once that has been completed, you will be let you know that. You can see that the play button will be enabled. If you are playing it, it provides over the respective the portions. So, you can use that scroll button for zooming up, left click with and keep on moving, that is a pan will be available. So, let us try in the last module, that is going to be your R and P. Once you select your R and P here, load the robo, you will get here this thing will be available. So, without changing of over any of these values, I will go for our FKIN with a default condition. In order to have a better view, if you want, you can scroll down or scroll up based on our requirement. Go for F kinematics. So, analysis complete will be there, then go for our play. So, now you can see that the first joint makes a rotary motion, the second joints making a linear motion. You can see again on the playing back. So, it starts moving backwards. So, this will be provides a detailed behavior part of it, how it works for the given data has been provided to us. So, this is the plus point of this kind of an robo analyzer. I expect you to do more practice. by changing the degrees of freedom different values, you can change the different degrees of freedom and try to experience the behavior of the robot.